Almost a decade after the 2010 Deepwater Horizon disaster,
There we go.
hundreds of scientists are assessing the impact of the largest offshore oil spill in U.S. history. What follows are some of their stories, intimate portraits of research, innovation, and discovery.
I'm Samantha Joye. I'm a professor of marine sciences at the University of Georgia in Athens, Georgia. I'm a microbiologist by training, but I do quite a lot of geochemistry as well, and my research involves understanding how microbial populations that naturally exist in the ocean at low numbers can respond and bioremediate pollution like oil. What regulates their activity? What's their maximum capacity? Oil seeps naturally into the environment at thousands of seeps across the ocean basins, and we don't see oil slicks on beaches. We don't see tar balls on beaches. What we see is that these communities can handle slow, diffuse inputs of oil. When you have a massive input of oil, that's a problem because you've overwhelmed the natural capacity. So the question is, how fast can they respond? How effectively can they respond? And what regulates the response? So if we can understand and document the factors that regulate the response and perhaps figure out a way to naturally enhance or accelerate that response without the use of chemicals and other compounds that are detrimental to the environment, then we have a good chance of aiding in designing a better, greener response to hydrocarbon pollution. The Gulf ecosystem is doing better than a lot of people thought it would be doing. I think that's fair to say. But there are still areas that are heavily impacted, like Deepwater corals on the seafloor. We've still got a lot to learn, and the fact that no single component of the ecosystem recovered on the same sort of time period, that makes documenting recovery and documenting the impacts of these sorts of incidents very, very complicated. When I started doing science 24 years ago or so, you had individual investigator projects. That was the norm. The Deepwater Horizon was, I think, not the first case of collaborative science, but it's certainly one of the best examples of collaborative science. And I think that what it sort of illustrates to the world and to the general public is that the sum is greater than the one. When you bring in other collaborators, you have this collective wisdom that develops, or this collective intuition that develops, and you begin to look at things in different ways. You challenge each other. You force each other to think outside of your little box that you're used to being in and where your comfort zone is. And I find that incredibly stimulating because you're exposed to new ideas, you're exposed to new technologies. It broadens your thinking, it broadens your perspective, and it allows you to bring in tools and apply tools that you might not necessarily have thought to apply to the problem. So I do think it's the wave of the future.
Today, the scientific community is working together to push the boundaries of what they've learned about oil spills and what still needs to be discovered.